Hello everyone, today we are going to go through Ice Cream Parlor, which is a problem under search section of algorithm on Hackerrank. So without wasting time, let us have a look on the problem statement. So in this problem statement, you receive an integer donating m and you have an array. And you are supposed to find out the indexes of the two elements in the array in such a way that the sum of those two elements is going to give m. So globally, that is what you're supposed to do here. So you have an array with an element and you're supposed to find out the indexes of the element on which the sum of those elements will result into m. Let us take this one for instance. We have our target, which is 6. The element that the sum will result into 6 are actually 1 and 5, and we can see that the element 1 and 5 are at position 1 and at position 4. This is one base index. So you have 1 position, the element 1 is at position 1, 1, 2, 3, 4, and at position 4 you have the element 5. So here you should return the array consisting of 1 and 4, because those are the indexes of the element, which by summing them you have the output 6. Let us see another example. So here you have two cases. This is the first cases with an array, a target of 4 and then an array of 5 elements, right? If you want a target of 4, what are the elements that you can sum to have the result 4? Actually, the elements are 1 and 3. What is the index of 1? Index is at position 1 and 3 it is at position 4. So you should return 1 and 4. That is why you have 1 and 4 here. The same for the last one. So basically, that is what we are supposed to do here. You are supposed to take an array, find the two elements into that array in such a way that the sum of the two elements will result into this m. So now that we are fully aware of what we are supposed to do, now what will be the implementation of this? There is one straightforward approach which consists of having a double for loop. You have a first for loop which will loop from the first one to the last one, and you have a second for loop which will loop from the next element. That means if this one is starting at from 0 till n, the other one will start from I plus 1 till n. And then by looping, so you just need to check if the element at position of the first index is equal to the element of the position at the second index. That means I and j. But the issue with that approach is that it will result into big O of n squared, and that is not what we are going to implement here. So we are going to find a more an approach of big O of n. What will it look like? So the first thing we are going to do in our approach is create a map. We create a map because we want a data structure where we can find an element with big O of 1 complexity, and having checking an element in a map is basically big O of n, big O of 1. Now creating an element, after that we are going to create a vector. The vector is actually the element that will store the response, because we want to return a vector of those two indexes. After that, we are going to loop through the input, and for each of the elements in the input, you are going to compute the complement. What does that mean? That means if we agree that we have two elements into the array such a way that a plus b is equal to m, that means if you have an element a, the potential b is actually m minus a, right? So we are going to compute a complement, and from that complement we are going to check if it exists in our map. So we are going to check if the complement exists in our map, then that is the solution. So we return that solution. If it doesn't exist in our map, then we add it to the map and we continue to move forward. And at the end, we return the array result because we need to return a vector anyway. So even if we perform a return here, we definitely need to have a return here, otherwise the function will complain. So what would it look like in implementation? We are going to have the map that we were talking about in the beginning. After the map, we have the vector. After the vector, we now have our for loop, which will loop into the array size. After looping through the array size, now we're gonna compute the complement. That means the potential pair in such a way that that element plus the current element will give us m. Now that we have the complement, we need to check if that complement is already in our map. If it is in our map, then we assign to our response this pair, which is actually the index of the first one and the index of the new element, the current element, to make sure that they are actually in order. That means this one is lower than this one. And now at the end, we need to, if it doesn't meet this condition, we now add the element to our map. Now you don't really need to have an else here because you have a break here. So definitely if you find yourself here, that means it is basically the else of this. Now after this, you just need to return the response. Let us run and see what it gives. We have a congratulations, everything is green. I do agree with you that we can perform some optimization in this. Maybe we can remove this, and then here we can directly return, and you don't have the break here anymore, and here you just return this. Basically this, since we are sure that in the constraint it has been said that there will always be a unique solution, that means we will never land here, but we need to have this just to match the function signature. Yeah, that is optimization we can do. If you want, you can remove this count. Yeah, if you want, you can use the second approach, but it's up to you. But yeah, this one will also give you the right answer. Let us submit and see. We have a congratulations. So if you know any way of improving this, I'll be really happy to interact with you regarding this. See you on the next video. Ciao.